All right, let's go ahead and get started. Welcome to everybody. Welcome to the SharePoint Professional Developer Penthouse Suite on the 5th floor. All right, exactly where we all belong. For the next hour and 15 minutes or so, we're going to talk a little bit about complex problem solving with the new HTML5 APIs. If I haven't met you yet, this is what I like to refer to as my NASCAR slide. This has all the different things that I do, involved in the community. These are the different books I've written, and these are the banners on the side of my car. I have my own company. I do some training under Critical Path Training and Pluralsight. And I've just received my 9th award as a SharePoint MVP in January. So, thank you very much. So my point to you is really just that for the last 10 years, I've done nothing but SharePoint development. That's all I do. I'm in it pretty deep. I'm really a working programmer, so I spend about 75% of my time doing project work for others, and about 25% of my time in front of groups like this talking about how to get it done. Well, it occurs to me that there's been a big change in our relationship with SharePoint from 2010 to 2013. I'm sure you guys would agree with that. And sort of my sub-theme for all the talks that I'm doing this week is what I like to call from bricks to houses. And the reason I say that is because when I used to think about developing in SharePoint 2010, and I would teach others to do it, I would say to them that basically the way to think about what you're doing is that SharePoint 2010 comes with a bunch of features. And as a professional SharePoint developer, what you create is features. Now, features that you create are created using the same exact tooling that Microsoft uses. So you're basically just taking the product and adding features that Microsoft could have put in the product, but they didn't. So we're sort of had that relationship, that very intimate relationship with SharePoint, where we were like a brick in the wall of SharePoint. We sat in there with workflows and pages and libraries, and we made our own web parts. But in 2013, that model's really changed a lot. Sure, you could argue with me that some of the things you do extend the platform, but really you're responsible for a lot more in 2013 than you were in 2010. So to me, I think about it more like building an entire house than just building a brick that goes into the wall. And those houses are app parts, SharePoint-hosted apps, and provider-hosted apps. So what it really means is that we've had a significant change, a sea change in the skill set required to be a professional SharePoint developer. All right, so it used to be that if you're a professional SharePoint developer, then you got brought into a dark room, a dark smoky room, and people would explain very secret things to you like CAML, and that 101 is a document library. And unless you knew that kind of stuff, you couldn't be a professional SharePoint developer. It was hard. It was a hard way to get in. But now what's happening is because we're becoming more like web developers, a lot of the skills that we could sort of ignore, like enterprise-level JavaScript, have now become critical for us. So that's kind of the theme of everything I'm doing this week, is as we're moving from bricks to houses. So in this talk, what we're going to do is we're going to take a look at some very specific solutions around HTML5, because HTML5 and CSS3 have now become critical skills for us as well. So we need to know these and begin to implement them inside of our solutions. So we're going to take a look, as I said, at some very specific things like making responsive iframes or having app parts communicate with each other. And we're going to do this by using the HTML5 APIs as an excuse to get familiar with them and see the types of things that they can do for us. All right, before we do that, we're going to have a quick HTML5 overview. There's a whole bunch of HTML5 in HTML5. When people use that term, they say HTML5. It's really an umbrella that covers all kinds of stuff. It covers new markup inside of HTML. It covers style sheets, so people will say HTML5 when they mean to include CSS3. And it also includes the JavaScript stuff that we'll be talking about. So just a quick overview of HTML5 and the stuff that we're not going to be talking about in any great detail. Here's a simple HTML5 page that shows us some of the new markup we're going to use and some important things to us as developers as we begin to use HTML5. This new, simpler doc type up here at the top signals to your browser that this is an HTML5 page. And so one of our big concerns is the browsers that we have, what parts of HTML5 are they going to be supporting? So that's a critical thing, strategic thing for you guys to think about, is what browsers am I supporting at my organization? What's our plan to move to browsers that fully support HTML5 so I can more and more take advantage of the new capabilities? So we see that, and then we'll also see down here this article, which is a tag that's the new semantic element. So HTML5 has this idea of semantic elements, which are sort of like divs. You can think of them as divs, but they're specialized divs really designed for search engine optimization. The idea here is that if you're making your HTML pages out of divs and using style sheets to move things around, then when the search engine comes by, it can be confused as to exactly what's important in your page. And HTML5 allows us to designate important things using tags like article, which says this is the main body of the page. And when I do a search, this is the stuff that's important. We also have new functional elements down here. So we can do things now like play videos directly in the page, which means a lot of the stuff that we had to rely on before, like plugins, go away for us in HTML5 as the browser becomes more and more powerful. Here's a list of some of those new HTML5 semantic tags. You can see again that they're basically focused on search engine optimization so that you can easily identify the headers, the sections, the main body of the page, asides, and the footers. And you're free to use those in your pages and the apps that you create. You'll see a lot of this stuff in some of the demos that I do for you. I'm just not covering it in detail in this talk. We also have these new functional elements. I pointed out things like the video tag, which lets you play videos directly in the browser without having to have something like Flash. There's a bunch of others here that let us do visual things like the canvas, which lets us draw shapes, scalable vector graphics, which lets us draw graphics that scale nicely regardless of the platform, the size that we're showing them. All these things are elements that we can use. And along with those, when people say HTML5, they often mean CSS3 as well. So there's a whole bunch of CSS changes that allow us to make pretty things. And that becomes very important to us because more and more as app developers, we're responsible for creating that UI, right? If you're making a brick in the wall in 2010, a lot of the UI stuff is taken care of for you. But if you have to build an entire house, then you're often responsible for more of the UI than you were in the past. So these pretty things become important to us as well. But what we're here to focus on primarily are these APIs. So here are the APIs. We're not going to do every single one of the ones that are on this list. But what this is, when we talk about the APIs, is new browser-based functionality that you can access using JavaScript. And then it makes really JavaScript a much more powerful enterprise programming language than it had been before. And that's really why you care about them, because as we move more and more to this model of client over HTTP, these things become more and more important because the browser now is that primary application that's being used. So the more power I have in the browser, the better it is for me. Okay, so with that as our setup, let's go ahead and move on to the first thing that we're going to solve, which is responsive app parts. Responsive app parts. So, responsive app parts, what do I mean when I say that? Well, here's the challenge that we have with app parts. As you know, app parts appear inside of iframes, right? So, web parts were much more of an intimate relationship with SharePoint, and app parts are much more, stand on their own, as we've been talking about. And so, we're fine that when we try to move to app parts, we lose some of the nice things that were around when we had that intimate relationship. So one of our challenges is that an app part is always going to appear in an iframe, and it's really SharePoint that controls that iframe size. So as the hosting page, it says, here's how big I want to make you. You show inside of that. But the app part itself may require a different size than SharePoint is offering, and so it needs to be able to ask SharePoint for a different size. And some of you are probably familiar with SharePoint support for post message. We'll see that. But also, the app part needs to respond to what SharePoint is doing. So one of our big challenges that we have, one of the things that you should be thinking about when you're considering the creation of your apps is being responsive to different devices, right? So we talk about responsive design, and there's a couple of great sessions this week on responsive design. But basically what that means to us is that we're going to write one app, and it's going to detect the device that's looking at it, and it's going to change the way it shows things based on the device that's looking at it. So this is a two-way conversation, is my point. SharePoint is saying, listen, I'm being looked at on a mobile device, and the app part is saying, I need this kind of window to show this information reasonably, and we have to negotiate in some way to come up with something that will work. And the solution that we're going to employ that is going to allow this two-way negotiation is media queries and post message. So what media queries allow us to do is it allows us to do styling based on device properties. You care very much about this as an app developer because we want to be mobile first, right? That's the buzzword, mobile first. It means the stuff I create should work on any device that looks at it. That's got to be a first consideration, not let's make it work on the desktop and then figure out what we're going to do later. So if we want to be mobile first, one of the primary things we're going to do to make that happen is to utilize media queries, which will allow us to ask the device questions about what it supports and then respond by styling our page so that it looks great on that device. Here's some examples of using media queries. The top one here, you can see we have a CSS media query on a linked element. So in this case, you can see I'm using a link, and the media query is saying max width 800 pixels and then referencing a style sheet. So it's asking the device if your maximum width is 800 pixels. If you're in that 800 pixel window, then I want you to use this style sheet. And so we could have multiple style sheets that are now applied based on the maximum width of a particular device. We can also do it within the page, so you can see I have style elements there, and then I'm using the @media construct here, and in this case I'm saying if your orientation is portrait, then I need you to apply this style. So I'm going to change it based on how you're looking at me. And finally, we can also do it with JavaScript, so at the bottom you see that we're doing window.matchMedia. And that call is simply going to allow us to attach an event handler to the device width 600 pixels in this case, which will fire when the device changes and its max width is 600 pixels. So if we're looked at by something that meets that requirement, we'll get an event. So that's very cool because that allows us both a programmatic and a declarative way to manage our responsiveness. Okay. Coming now to the communication part from the app part up to SharePoint, media queries is allowing SharePoint, when it looked at something on a different device, to tell the app part, hey, I need you to change the way you appear. But the app part needs to negotiate back, and it's going to do that through post message. Post message is an HTML5 method that allows an iframe to talk to its host and say, you know, here's some information that I need you to have. So communication from the iframe to the host. In the case of SharePoint, we're very concerned about sending this message that says, here's the size of the window that I need. And we'll see how to do that in just a second. It does work across domains, so we're allowed to send this message across domains. And there's lots of other uses than the ones I'm showing you right now. So you do need to be concerned about security. So when we have these messages cross from the iframe to the main page, they'll pass in the domain that they're coming from. And it's important that we do things like verify the domain that's actually pushing that message at us so that we know that it's whitelisted. And secondly, that we purify that message to avoid any script injection. One of the things that I'll just emphasize to you that I really want to put in the forefront of your mind is that as we move more and more to cloud-based development, security becomes more and more important. So it's no longer good enough to have, you know, your web service use anonymous access and then take the credentials for the anonymous account and give it full rights to the SQL database, right? That can become a problem when you're out there in the big bad world. So I try to put the security stuff front and center in everything that we say. All right, so here's some code that shows how this works. This is the post message stuff. So what happens is the sender will get a reference to the iframe, which you see at the top, using document, in this case, get element by ID, and then this content window. And then it can simply say post message and send some data like hello over to it. If you want to receive this information, then you're going to attach an event listener in code on the receiving side, and you can see I'm just receiving a message, and that message will get the domain, the URI, the data that was passed, and the source. And that's going to allow you to do something like whitelist it. In SharePoint 2013, out of the box, SharePoint 2013 is already listening for resize messages from app parts. So what that means is that we can use code formatted the way you see down here at the bottom for an app part to request a different size window from SharePoint to show itself. So as the app part is changing, it says, I need this size. As the device is changing, SharePoint's saying, I need you to look like this. And those two things together are how we're really going to negotiate the ultimate size of the app part. Okay, so let's take a look at that in action here. I'll jump over to my machine here, and let me just show you the app itself here as a starting point. So we'll come up here to the browser, do quick navigation. And I'm going to show you this app I wrote. So this is not an app part at this point. This is just the full-size app. And basically what I have here is a corporate calendar. So this is a pretty cool solution because what it does is it's a search-based application that runs a search across the entire farm looking for events and then aggregates them into a single calendar. So it basically makes a corporate calendar for me on all the calendars that are in the SharePoint farm. I have a little functionality, you'll see a link up the top that allows you to include or exclude some calendars that you want. And the cool thing about this is that because search is security trimmed, all the events that show up here are events that I actually have access to, right? So I'm not going to see things I can't get access to. It's a personalized corporate calendar. So that's pretty cool. You can see our events are up here. I've added those. And I can navigate a little bit. So if we go backwards, you can see I apparently had a golf trip in January. I must have missed that, but there it is, right? So you get the idea. I'm navigating through my personal calendar that's rolling everything up. So that's cool. I like that as an app, but I might also want to put that somewhere where it's a little bit more useful. So we've turned it into an app part. And then if I click on the home page for my portal, you'll see that I now have that calendar embedded as an app part in the home page. Could be pretty useful there, right? Corporate calendar on the home page of your portal. Nice. But now what we're going to do is we're going to pretend that we're looking at this in different devices. So I'm going to go ahead and change the browser size here. And when I change the browser size, you'll notice that this thing is responding. So as it gets less and less horizontal space to render, it's changing its view. It's down to a day view now. And if I keep scrolling down, you can see that it now shifted from being stacked left to right now to being stacked vertically. And if I keep going down to, say, phone size, it shifts again, and it goes into this sort of calendar view that's appropriate to be seen on a phone. So what you're witnessing there is responsive design, right? As the device changes its ability to render, then the app part is responding by showing a view that's appropriate for that particular device. But think about it for a second. Normally, app parts, web parts, whatever, you go in and you kind of say, how big window you want to give it. But there's no way to know in this kind of scenario how big the app part really needs things to be. So we have SharePoint asking it to be smaller, to change something about it, and then we have the app part responding back saying, this is the size I really need. All right, so let's take a look here. I've got the code for this particular app up. Let's take a look at some of the details of how that happens. So first thing I want to do is just stop here on this particular code. So this is the code that just shows the data layer of the app, and you'll see that we're basically using REST calls to get our information. If I scroll down here, you can see me building up the events, right? So here is the actual RESTful query for the date range of the calendar that you're interested in, the URL that says what properties I want back, title, event date, things like that. Here is the actual AJAX call that runs that search-based application, and then it comes back as XML in this particular example. We parse it out and build the information. Okay, and so the way we get this stuff to show once we do that RESTful call is we come and put that into a special plugin that I'm using, which is the Full Calendar plugin. So a shout out here to the Full Calendar jQuery plugin that I'm using, which is super for taking these events and putting them inside a simple calendar. So this particular app now that we want to turn into an app part, the way we're going to do it is by adding a new app part. So up here we can see the corporate calendar part. And actually what I'm going to do here, just to make sure we've got the ability to zoom in when we want to, is let me go ahead and just fire up Zoom it here, in case you want to show anything more closely. All right? So here's our corporate calendar part. Right? There it is. Great. And then if I bring up the Elements XML for it, you'll see that this thing has a property. So this is the real key to what I'm doing, is this has a property that says what view you want the calendar to be in. Month, small month, basic week, you get the idea. So this calendar has the ability to change its view. And then what we have is SharePoint telling us what view that it wants. The way that SharePoint is telling us what view that it wants a little drawing here we can take a look at. Here's the architecture of how it's done. There's a script part on the home page that's running media queries, finding out the device size that is currently applicable. And then what it's doing is it's calling the app part and setting its view. So it's saying, I want you to be, you know, a tiny little 1-month calendar if you're being looked at on a phone. So those media queries tell the app part how big to be, but then the app part comes back and says, well, if you want me to be that size, I need you to change your size as well. And then it can come back with a post message that says how big it should be. So here you can see that when we're told what view, when SharePoint comes in and tells us what view it wants, then the app part turns around and says, that's fine, I can be a monthly calendar, but you need to give me this size window in order to display that. Right? So now we have that two-way communication going. And then finally, to wrap it all up, we can look at the actual code that's in that script part. So here's the part where we're doing the media queries. So we're using window.matchMedia and then attaching listeners and changing the view of the calendar. And the way the view of the calendar is getting changed is I'm simply changing that view property for the iframe. So the point here is that we've used those HTML5 capabilities now to have that two-way communication between them that allows that script part to tell the app part to change something and allows the app part to come back and request something different. Okay, next one, Ajax navigation. Here's another key thing that you need to keep in mind as you're building these modern apps. Ajax navigation is a concept that goes along with something called single-page applications, or SPAs. You'll hear a lot about single-page applications this week if you attend certain events or SPAs. And a single-page application is the idea that you can create an entire application that uses just a single page. And that we're going to navigate from views to views, from partial views to partial views, and we're going to have a rich user experience that happens all on a single page. Well, when you begin to build these single-page applications, what happens, though, is you want for the experience in the browser to be the same in regards to the history management. So in other words, if you're going to put everything in a page, what you're going to see as you go along here through the demo is you have a real challenge with what the forward and back buttons mean to an end user as you're doing a single-page application. So if you change the view of the page and they hit the back button, what are you supposed to do? So HTML5 gives us access to the history object. And when you first see the history object sort of in the list of things that HTML5 supports, you go, Okay, I can access the history. That sounds nice. But then you realize it's there specifically to support spas. That's why it's there. So you can manage the history while you're writing single-page applications. So the first takeaway from the talking part of this is that you want to be in the business of creating single-page applications. That's important. And then if you're in the business of creating single-page applications, then what you're going to need to do is be concerned about several things. But one of the things to be concerned about is the management of that history. So let's take a look at an example of accessing the history for the purpose of creating a single-page application. Okay, back to our environment here. Jump down here and go to our demo of Ajax navigation. And I'm going to show you a little app here. This is an app that manages customer information and contact information. So apparently SharePoint is working on it there, so I have to give out a t-shirt. Every time SharePoint's working on it, I have to give out a t-shirt that says working on it. So there you go. And I'm sorry back there, I'm just not that strong, so some people up here are gonna benefit from this. Okay, so what you're looking at here is a single-page application. Very important, single-page application. If I come up here and I point at the URL and I do my little zoom it thing, you'll see that this is default.aspx, right? Everybody with me on that? And now what happens is, I've got some information here with people. It's pretty straightforward stuff. There's nothing, the business rules here aren't very exciting. But I can page this. I go page 2, I go page 3, I go page 4, just like you would expect, right? And I can come up here to the URL, and I can zoom it in, and you'll see it stays on default.aspx. So this is a very simple example of a single-page application. If I go to edit something like this, I click on that, and I say I want to edit that. Well, sure enough, it's going to stay on default.aspx as well. All the CRUD operations that we're doing are all single-page applications. But the problem we're solving here is that now what happens if somebody clicks the back button over here? If it's one page, isn't it going to be a real problem? Well, we click on it and, oh, look at that, it went to page 3, and then back to page 2, and back to page 1. That's exactly the behavior that you want from a single-page application. To the end user, it feels like a multi-page application, but it's one page. And what that does is it makes the responsiveness and the end user experience so much better because it's kind of like you're using a desktop application, right? And also, if we go up here and we sort of hover over the back button and we click and drop it, oh, is that sweet or what? Right? So we've got these, we've actually got them in there as if they were separate pages. Okay, so how are we making that happen? Let's go ahead and take a look. So this is an application here that I'm going to use in several of my talks this week. We'll look at it in a little bit more detail. This is a pure JavaScript application built in what's called AngularJS. If you're not familiar with AngularJS, I'm going to have a talk called Third-Party JavaScript Libraries You Need to Know, in which we'll talk about Angular in detail. But what you care about AngularJS for now, for this discussion, is AngularJS is a framework for creating SPAs, single-page applications. So if you're going to be in the business of creating single-page applications, you need a framework or you're not going to be successful. It's very difficult to grind these things out from scratch, but a lot easier when you have a framework. And this framework happens to be Model View Controller, so it's an MVC-style framework. So you'll see over here in Visual Studio that I've got several controllers defined inside this little controllers folder, and one of them is for contacts. So let's go ahead and bring up the contacts controller. Make the code big so we can see it. Working on it. Okay, there's our code right there. All right, now, I'm not going to do the Angular stuff in great detail in this session. Just believe me when I say this is the definition of the controller right here, and this is the code that's going to run inside the controller. And then we're reading and writing some data here. And this is really where we want to stop here on this section that I've tagged as Ajax navigation. So in this case, what I'm doing is a couple of things to manage the Ajax navigation. The first thing is I'm using a little bit of jQuery to change the title of the page. That's why when you look at the history, it has different titles for all the different things that are in the history, because I just change it to something that's meaningful, and you can see here that I'm saying contacts and then the page number. What's really cool about this, though, is the use of the history object. The history object allows us to replace something that's in the history list or to push something new into the history list. And so what it does is it allows us to completely control what appears up in there, and basically what we're doing as we work through the different pages, as I click next page, next page, next page, I'm either going to replace the state that's there or push in some new state that's there that keeps stateful information about what page I'm on, and then I can get that back and change the view, right? So it's actually a pretty straightforward process. And even better, I've sort of goofed around with this for the purpose of being able to show you guys something cool, but even better, if you utilize the Angular framework and you utilize something called routing in the Angular framework, it actually manages this for you, which is really cool. Just takes care of the whole thing for you, all right? But the takeaway from this particular one is really just, you know, here's another key thing that needs to go into your toolkit as you're creating these apps, particularly as you're beginning to create them as single-page applications. All right, so that was kind of an easy one. Ajax navigation. Let's move on to something that's a little bit more fun. Let's talk about connecting app parts. So one of the things that I thought would be cool to do in this particular session is talk about how we could connect app parts together and mimic the type of connections that we had in web parts before, right? Because when we moved to app parts, we lost some of that stuff. So the challenge as we're defining it here is that web parts can be connected through the UI, but app parts really don't support that same idea that we used to have with web parts. And so how are we going to do this? So we're going to use two solutions. I'm going to show you two different ways to do this. Both of these are a little more advanced than the things that we've been doing. They're called server-sent events and WebSockets. So the first thing we're going to touch on is server-sent events. Server-sent events. Server-sent events are wicked cool. This is something to get excited about. What a server-sent event does is it allows a server to push data into your JavaScript client. It's one-way communication from server to client with an open pipe, meaning that whenever the server wants to communicate with your JavaScript, it just does it. And your JavaScript picks up that information getting pushed at you from the server. So that's what we're going to do. We're going to set up a server that pushes information, and then we're going to utilize Web API to write our service. Now, in this particular talk, I'm not going to go into tremendous detail about creating RESTful services in Web API, primarily because I have an entire talk coming on, what is it, Wednesday? Tomorrow? Yeah, coming tomorrow on how to build your own RESTful service. I will just say this as sort of a public service announcement. A lot of the communications that we have, a lot of the things that we see, a lot of what people are talking about are about consuming RESTful data, right? So SharePoint exposes REST API, you consume it. Everybody's talking about that. But if you're serious about client over HTTP, it takes you no time to realize you're going to have to write your own services. How are you going to mash up your databases with SharePoint stuff if they're not wrapped in a RESTful service? Okay? So REST, OData, the Web API become another critical skill that you have to master in order to really be able to create enterprise-level solutions. And so Web API is very cool because it supports server-sent events, and it supports server-sent events using something called the push stream content class. So you can see the basic code I've got up here on the slide. What it does is we have this method set up that returns this HTTP response, and then I'm creating a new push stream content and then associating a stream writer with that. Let that sink in for a minute. So what happens is I can push streams at the client. So imagine somebody's just like browsing the website and you decide you're going to push a video at them. You're going to decide you're going to push some other messages that pop up and display. Anything that you want, you have this open pipe through this stream now to write things into the client. Super cool stuff. Okay. In order to make this happen, then, the client is going to create an endpoint to receive those events using the window.event source. So in order to make this happen, we're going to check. You can see this code that we have here. We're going to check initially to see whether or not our particular browser supports the event source. So it's very important, as I said in the beginning, to know your browser and what HTML5 stuff it supports. I'll talk about this in the next talk on libraries you need to know. But modernizer.js is your friend there. Modernizer is a third-party library that lets you figure out what your browser supports so that you can do something else if it doesn't support it. But you can see in the code here I'm doing a rudimentary check to make sure that event source is supported. Then I create a new event source and I add event listener, which basically binds me to that stream. So here's how the JavaScript is going to receive that information. All right, well, let's take a look at an example of connecting these parts with server-sent events. And I'm just going to go ahead and open up the code here before we flip over. Uh-oh, working on it. I knew somebody would start that. Working on it. Hey, let me ask you a quick question. Does anybody in here really, really, really know how to use a hacky sack? Stand up if you do. Yeah, pretend it's 1991 and you're on the college campus and you're skipping class. Who knows how to do that? Matt does. All right, there you go. Have a hacky sack. I got hacky sacks to give away, so, you know, everyone's like, what am I going to do with that? I'll put it on my desk. Anyway, let's switch over. All right. Okay, so what I'm going to show you now is we're going to do this server-sent events thing here. And what I've got in my project is I have three things in here. The one that's highlighted is the message broker, and then I have a consumer and a provider. So a quick look at the architecture, then we're going to come back and look at it again. So what I'm about to do for you, right? So remember, the objective here is to have two web parts communicate with each other. There's several different solutions. Some people have done this with post-message, but we already did a post-message thing, so I didn't want to do that. But basically, if you want to have app parts talk to each other, you have to have some kind of message broker between them. So one app part talks to the message broker talks to the other app part. You could do this as simply as having like a list in the host web where one app part drops a message and another app part picks it up. But that's kind of clumsy because it would rely on something like reading it or polling, which we're not interested in. We want more of a fluid communication where one thing can push a message at the other, right? So what we're going to see here, and this is important, this is a little more complex than what we've done, so let's try to follow it. I have a provider web part and a consumer web part. And what they're going to do when they fire up, and watch this when I run the demo for you, what they're going to do when they fire up is they're going to check to see whether they're registered with the message broker, which is a web API service that I wrote. If they're not registered with the message broker, they will register themselves with the message broker. So they go looking for that, and they register. And they basically, the consumer is going to say what kind of messages it wants back. So there has to be a connection that's made then, right? So a human being is going to make a connection in a database that's associated with the web API that says this app part ID is connected to this app part ID. And then the message broker is going to look for incoming messages from the provider, figure out who's connected to it, and push them back out to the consumer. See how that works? All right, well, let's go ahead and see if I can actually make it work. So what we're going to do is I'm going to go ahead and start this up. So I'm going to come up here and just F5 it, and that's going to fire up my message broker. And the message broker is marked as the default start for this project. So what you're going to see is the message broker come up. If you're not familiar with Web API, it's going to start the browser for us, and then it's going to give us this thing that looks like a horrible error. But actually, it's only because there's no visual part to this service, right? So it's started, but there's nothing visual to show, which is fine. All right, so now what we're going to do is we're going to fire up browser here. And let's grab ourselves the clients that we're going to need. Okay, so I want to do this in Chrome, so let's go here. All right, so I'll do it in Chrome. And we're just going to navigate to the site where I have the guys waiting and click on, say again? Oh, come on, you're terrible. All right, watch what's happening here. So these guys should come up. That's probably working on it, right? There it goes. All right, super. Watch the messages coming up. All right, so what they're doing is they're checking their registration status with the message broker. If they like it, they give us the green check mark and they say they're all ready to go. All right, so what we have is this provider app part on the top, and then we have this consumer on the bottom, which is really just a JavaScript charting stuff down there at the bottom. And this is a very typical scenario, right, where you want to filter a bunch of things, say, on a dashboard. This happens to be, let's see, December 2013 to January 2014 gold prices, and we have a couple of different lines here, open, high, low, and close. And so then what I'm going to do is go up to the filter part, and we'll say that we really just wanted to see the open line. I'm going to go ahead and click the button here. Watch what happens. Ready? Boom. Sent, received, and then there's our single line. I can come up here and change this and say, let's do close. Okay, data sent, data received, and just the close line is filtering. That's exactly the behavior you want, right? That's exactly what we want connected web parts to do, and we're mimicking that exact behavior. Oh, well, thank you. Yeah, so I will point out to you, if you haven't gotten the source code for this session, this thing is in the source code for this session on Yammer, so grab it. I didn't hide anything from you. You guys can take this thing and pretty much fire it up in your own environment, and it will work. All right, let's take a look at how this thing was really done then. Okay, so we talked a little bit about how this thing is going to be registered. So what it's doing, if we look in the message broker, if you look in the controllers here, again, if you don't have tremendous experience or really any experience with Web API, put it on your list. You really need to know it. But I have 3 controllers here. One controller is the consumer controller, the other the provider, and finally the message controller. So basically the consumer and provider controllers are just wrapping SQL databases. So what happens is the consumer and provider can check their registration and make entries in the database saying, I'm here and I care about being connected. Then a human being would use another app that you created to look at the possible web parts and then make the connections, which is very similar to what you do in 2010, right? You look at them and you say, connect this one to that one. So that was the idea behind that. But those are pretty straightforward, just wrapping a database. What we really care about is the messages controller. So let's take a look at the messages controller here. Now, again, if you don't have a tremendous amount of experience with Web API, this stuff may look a little bit confusing to you, but I'm going to go ahead and just kind of shrink them down here and give you a little overview. So basically what Web API allows you to do is very easily map gets and puts and posts and deletes into methods inside of a controller so that when someone says, I want to post this, that data goes right into some C# code you have in the controller. And then you receive that message from the post, and you can do whatever it is you want with it. So it's a pretty straightforward model. What's going on here, then, is that we have 2 things that need to happen. We need to have the consumer basically subscribe, right? So I need to open up this stream that's going to allow the pushback to occur. And then I need to allow the provider to be able to send a message in. So what you're looking at here, if you see up at the top, this is our HTTP web response GET. So this is what the consumer calls to open up the stream. The code we kind of saw on the slide, but here's the key parts. We're making a new push stream content, and then we're opening up a writer that's going to we're going to create one for every subscriber in this subscriber queue that we have. So we're going to keep track of all the subscribers that we have active at any moment, right? Because in order for this to work, you actually have to have the browser open. So I need to know who's active at any given moment. And then I'm going to be creating this event stream that goes back to them, such that by the time you finish calling this get method, I've got a stream open on you that I can push content at. Well, then the provider will come in and post a message. So I have this class called message that contains the message, information I want to send. Another cool thing about Web API is that you can make C# classes, and those can be inputs to the methods, and that maps to the JSON that you create. So you're going to push JSON in the body that's going to get mapped to a class in C#, and now when you receive the information, you're just working with a class, in my case, the message class. And then when you post that message up, we're just going to call the broadcast method, and that broadcast method is going to loop through all the current consumers in the queue and send that message back out to them on the stream. So you can see in here the code that's writing to the stream. So as it comes in, it just gets written back out to everybody. And again, the cool thing about that is it's a push. So nobody has to poll looking for what changed. The moment it changes, you push it out, which is why you see the responsiveness, right? As soon as I type in open, the graph changes. And that's the behavior you want. I don't have to refresh anything. Okay, so that's the basic goes into and goes out of on Web API. And hopefully you're thinking to yourself right about now, boy, I got to learn Web API because that's pretty cool, all right? But now let's take a look at the JavaScript stuff. So I have two app parts here, the provider and the consumer. Let's go ahead and look at the provider. Am I in the provider or did I just click consumer? Let's look at the provider first, right? And we want to look at the connection stuff. So hang on, it's in here. Here it is. So here's some JavaScript. This is also written in Angular, but that has nothing to do with the mechanics of what we're talking about. I just happen to have written it that way. So this is the provider, and then the provider is sending in the message that it wants broadcast. So how am I doing that? I'm using jQuery AJAX, so nothing new here. This is what we've done all along. There's a service route, which is the root of the Web API service, and then API messages. Now remember, I had this controller called messages, and the way that Web API works is that the target URL for that is API / the name of the controller. So trust me when I say that what we're doing with this jQuery AJAX is posting to the message controller, and the posting to the messages controller is mapped to the code that does the broadcasting. And I am simply sending up the app ID and app body, which is the message I want to send, and the ID that, of this provider that wants to send it. And then the service can take care of broadcasting that back out. So a simple post from the provider is the point here. And then if we go into the consumer, we have similar code. And in the consumer, you'll see that what this guy does is it creates a new event source. This is the key thing here, right? So I'm going to create a new event source against the endpoint that has the push stream content. That's what opens up the channel from the server to me, and then I can wire in these events like the channel's open, there's an error, or the on message, which I get back any messages that are being pushed at me. And then you can see that basically I get an event E coming in, and then I do a JSON parse against e.data, which allows me to access the app ID in the body. So at that point, it's just a matter of responding to that data and changing the graph. See how it works? So there's a lot of stuff going on there if you haven't seen some of this technology before. But the key thing I want you to take away about server-sent events is that the thing about server-sent events is it opens one-way communication from a Web API service into your JavaScript and allows you to push messages at that client for whatever your purpose is. We're using it to connect web parts. Okay, cool. Let's go back. So I promised you two ways to do it. And the second way we're going to do it is using something called WebSockets. WebSockets. Another super cool technology. What WebSockets allows me to do is not one-way communication between the server, so from server to client, but now I'm opening up a two-way communication between client and server. So this allows me to do things like create chat clients. I could create a chat client in JavaScript where you send something in, it goes to the server, and comes back out. A couple of things about this. First, in order to make this work, you need a WebSocket server. So one of the things that I think is cool about server-sent events is that server-sent events are supported in Web API. If you're doing WebSockets, then you have to actually create a WebSocket server that will receive and send messages. I'm going to be using one called Alchemy. So you guys could grab Alchemy if you want. It's ridiculously easy to use. I've given you the URL there. That's the one I'll be using in the demo. You could certainly roll your own, but you can get started with Alchemy in probably just a couple of minutes. And then what the client does is it opens communication with that WebSocket server using window.websocket, and I think you'll find the programming to be pretty straightforward. Here's the code for the WebSockets here. When you open up a connection to the WebSocket, you can see that you're going to use a new WebSocket object, and then you're going to provide the endpoint that you want to talk to. The WS:/WAC is the protocol for WebSockets. So you're going to call it on WS:/WAC. And then what you're going to do is, much like a lot of the other demos we've seen, you're going to attach event handlers that tell you when the socket was open, when the socket was closed, when there was a message that came from the socket. And then you can also send your own messages to the socket. Down here at the bottom, you see WebSocket.send. So the key things here are the WebSocket.send and then the on message up here that enables two-way communication. The other thing is I've kind of hid some information from you here that I'll let on now, which is Internet Explorer doesn't support server-sent events. So it's a little disappointing. You saw me cheat, and I used Chrome. Working on it, yeah. That's a lot of T-shirts. That's a lot of T-shirts. But Internet Explorer supports WebSockets. So you can use WebSockets in IE to basically do the same type of thing. And then we're going to do it a little bit differently here. But let's go ahead and flip over and take a look at this one. Let's get the project open. All right, so we'll open up that code here. And this particular example that I'm going to show you now, I took a little bit different path with this one. This one's much more straightforward, right? I still need some kind of message broker, if you will, but in my case, that's the Alchemy WebSocket server. So because we have this two-way communication now, there's not really much difference between provider and consumer in this model. Both can open up a connection to the WebSocket server, and they can send and receive events. So your role as provider or consumer is really more contextual in this sense, right? What am I doing? Do I want messages or do I want to send messages? But this is basically what we're going to follow here. And for this particular one, what I'm doing is changing the model a little bit. So instead of having connected web parts that respond immediately, I decided for a little twist, what we do is create a message queue. So what I'm going to show you is creating a message queue in which one web part pushes messages into the queue, and then the other web part pops them off the top. So we're going to use a push pop, right? So first in, last out, right? First in, last out approach. And here we have our project, and just like the other one, you can see the default project here is the WebSocket. So we need to go ahead and fire up the WebSocket to get this thing to work. All right, and now you can see that I'm running here this socket server that's running in the command window, right? So this is my point, is that it's not the same, it's not as smooth and easy as just having to create a web API service. I now have this separate thing that's running. So in some way you have to create a socket server. Again, I'm just using the Alchemy one to make it easy. But let's go take a look at how this might work. So what I've done for our example here is we're going to come into our message queuing example. And what I'm doing here is I thought this would be kind of appropriate for SharePoint Conference. We're going to generate swag tickets. So the idea behind this example is that, you know, I'm doing a marketing thing where I need to generate a certain number of swag tickets. And then if you come to the website, it's going to say, oh, congratulations, you know, here's a ticket that you can redeem at our booth to get some swag. But I want to control the number of these tickets that go out. And it's going to be kind of in a first-come, first-served basis. So what I've got is a ticket generator here that says how many tickets do you want to create. We'll go ahead and say we want to create 5. Also, by the way, you know, we're not doing this in any great detail, but you see the validation statement right here that says number of tickets is required. Notice that when I type into the thing here, it disappears. That's part of the HTML5 forms capability. If you're not familiar with HTML5 forms, write that down. That's another doggone thing you got to know after this week, right? But it gives you support in the input box for validations, validation messages, and gives you more than just text. There are dates, telephone numbers, emails, all the kinds of stuff that you really want. Makes a lot of the stuff that you guys were talking about in the last session possible. But at any rate, I put my 5 in there. That's good. Now, you'll also notice in here that I'm providing some status information. You see the ready and the OK. I'll go ahead and click Generate. And what it does is it comes back and it says, OK, we generated 5 tickets. If I come to the Alchemy socket server, you'll notice that we did, in fact, exchange those 5 messages. So you can see that we have ticket 1, 2, 3, 4, and 5 that went into the Alchemy server. And the other thing I want to point out to you is if you just take a look at the messaging I'm sending in there, the socket server is just a message sending mechanism. So you kind of have to decide what your protocol is. So to keep it simple, what I do is I'm sending in information about what queue I want to interact with. In this case, it's the swag queue. And then what operation I want to perform. So you can say create, or I created the swag queue, and then I pushed 5 tickets into the swag queue. Make sense? But I just made that up. You can make up whatever you want, okay? But it makes it simple. Okay, so now we're going to go back, and here we'll go to ticket redemption. So now we imagine we've generated all these things. We go to ticket redemption, somebody comes into the page, and they get swag ticket 5 because it's popping the first one off the queue, right? And then if we go back to Alchemy, you can see there was a swag subscribe and then a swag pop that occurred down there. And if I refresh the page, you'll get the idea. There goes ticket 4. There goes ticket 3. There goes ticket 2, right? So you get the idea. So what we're doing is we're communicating between 2 app parts, both the ticket generator and the ticket redeemer were app parts. Well, what's cool about this is they're not on the same page, right? So now we have cross-page connections, which is another very cool thing that we would want to do with these, right? And again, this is just an example of how to use this particular technology. You could use it for lots of things. It doesn't have to be for connecting web parts, but it's a great way to understand it. All right, let's see how that was done. Let's come back to the project then and look inside our message queue here. All right, so what we're doing, this code that I brought up is from the Alchemy server here. So what happens when you utilize Alchemy is it's basically a DLL that you are going to add to your project, and then you're going to do some customizations on that. So I have a simple command line project, and so most of the code we care about is here in the program code. First thing to note is that I'm maintaining 3 different concurrent dictionaries here at the top. So I have the online connections, so who's actually connected to me at any given time. The actual message queues, right, because the model we're putting together is create and subscribe to a queue. And then remembering the subscriptions, so this particular web part is subscribed to this particular queue. All right, if we go down a little bit, you'll see that we have an onConnect method right here, and this onConnect is just the code that runs when somebody makes a new connection to the WebSocket. And you'll see that all I'm doing is adding to the online connection so I can remember what's been added. Then, once you're connected, you can go ahead and send messages. All the messages fall into the on-receive, where you can see we get the message. And then I do something pretty simple. I pull out the operation name, because remember, I'm following queue, operation, data, sort of my made-up protocol. And I can tell whether you subscribe, unsubscribe, create, push, you get the idea. And so the creator will come in, the provider comes in and creates a new queue. We're going to add that into the message queues collection to remember it. Then it can push messages into a particular queue. And if you call and pop, you're going to pop messages out of a queue. And you can see that's pretty straightforward stuff, right? So this is a pretty powerful setup that actually is not very difficult to program against. You kind of just have to decide what your messaging protocol is and then follow that. So that's the server side of the house. Now, on the app side, I have this app called the Swag app. And the Swag app has two app parts in it, the ticket provider and the ticket consumer, right? Straightforward enough. And then if we go into one of these guys in the script section here, we can take a look at the JavaScript side of the house that makes this work. Let me just find where I got that thing. Socket. Should be in the services layer here. Yep, there we go. Okay, so I have a service here that connects to the socket. Now, this particular one is also written in Angular. And one of the things that Angular allows you to do is create what are called services. And services are things you create that are available across the entire app. So I've simply created a socket service here. But what we really care about, what I want you guys to get, is that you can see that in order to connect, what I'll do is create a new WebSocket object. And that WebSocket object will have the endpoint of the WebSocket that I set up in Alchemy, and that gives me the ability to connect. And then all I have to do is connect the various events, like on open, on close, on message. So this is where I get my message back. There's the error right there. And then if I want to do something like create a queue, then all I'm going to do is send the queue name and the create command. You can see subscribe, push, pop, all of it's right there. So the reality is, although there's a lot of complexity underlying it, it's relatively straightforward to take something like the Alchemy server, program up how you want the server to behave, and then write JavaScript that, come on, it's big so you can see it in the back, and it still fits on one screen, right? So this is a pretty achievable type of thing to do, and now you've got connections going back and forth. And I would just invite you to sort of sit back and let that simmer in your mind and ask yourself, what kinds of things could I do with these technologies? As I said in the beginning, you could use this to do things like messaging, right? So tech support messaging works through this type of scenario as well. Okay, so that's getting two things to communicate. More ideas that we can take away. The next one I'm going to talk about is multi-threading. So the challenge that we have with JavaScript is that JavaScript is single-threaded. Now, there's some good things about being single-threaded. Mostly you can't get yourself in trouble with multi-threads, right? So you know things are going to complete in a certain order. But there are some real problems with the fact that JavaScript is single-threaded. We've probably all experienced this because, I mean, really, have you noticed that when you go to any website now, even reputable websites, they got so many of those little things that say, you know, earn $1 million with this one simple trick. Did you know that insurance only costs you $5, right? And then all those things have videos that play the moment you hit the page, right? Right? And then you go, man, all I want to do is see what the weather is. And then it goes, I'm sorry, there's a long-running script, right? And you go, well, let me get a cup of coffee and come back, and then maybe I can find out what the weather is. That whole issue is caused by the single-threaded nature of JavaScript. because it's busy doing something else, and it can't render the weather for you because it's busy doing something else. So as we put more and more information into our apps and show more and more things, then we'll run into this same problem too, right? So I've certainly seen it where you have very complex jQuery plugins or something like that that are maybe rendering a tree view, and it's trying to draw all that stuff out at the same time. You got a head nod here, yep, so you've seen it, and then the app becomes, you know, sort of not interactive at that point. So that's the challenge that we have. In HTML5, the solution that has been introduced to help us deal with that is called web workers. Web workers. What web workers allow us to do is basically spawn a new thread so we can take intensive types of operations and put them somewhere else while allowing the main thread to continue without blocking. If you're going to work with web workers, then there are two different kinds of web workers you might care about. They're called dedicated and shared. Pretty straightforward idea. The dedicated web worker is dedicated to one caller. So it means when you ask it to spawn a thread, it's tied to one caller, and it does some work for that one caller. Shared web workers allow you to support multiple callers. When you're inside the web worker, there are some limitations that are important to know. So it's not like you just fire off some JavaScript and you can do whatever you want. When you go into a web worker, for example, you cannot access the DOM. So you're not going to go over to a web worker and start running jQuery to magically change a bunch of things on a separate thread. That's not allowed. Basically, what happens is, you should sort of think of it as, I go over to this warm, safe environment where I can do intensive calculations or intensive data processing, and then I have to send the answer back when I'm done with that. That's the way this is set up to work. But if I'm doing that, if I'm over here doing something that's intensive, then the other JavaScript code can be running jQuery, right? That's the idea behind this, right? When you're inside of it, you have access to this keyword and self to reference the web worker itself. So you're going to see code that references this and self, which basically means me, the web worker, in my nice little warm, safe environment. You can also bring in other scripts to the web worker by using import scripts. So you are allowed to pull in other libraries to the web worker. It's just that you're not allowed to do things like touch the DOM, right? So you're expected to it's sort of a black box, goes into, goes out approach. All the communication between the web worker and the client is done via post message. So we've already seen a little bit of post message. So basically when we spawn one off, we're going to be able to send a message over by posting it and then send a response by posting it back. Here's a little bit of summary code to see how easy it is to make it work. The top part is the client right there. So in order to get a new worker, the client is going to ask for one, a new worker, and provide the JavaScript that it wants to run on the other thread. So you're going to make a separate JS file that you're going to run on the other thread, and then you're going to bind an event listener using add event listener so it can talk back to you when it's done. The last line of code you see up there, worker post message, that sends the input message over to the worker. So you're going to start the processing by posting a message to it, send some kind of data that it might need to get started. Inside the web worker itself, you're going to add an event listener to receive that initial post message from the client that's calling you, and then you're going to do something. And then you'll see this self, right? Remember, self refers to the web worker, dot post message, which is analogous to the sort of worker dot post message above it. And that's how you send the response back. So it's a pretty simple goes into, goes out a type of thing. And the idea is that while you're in here working, you're not blocking the main thread. OK, let's take a look at an example of something like that. Let's go ahead and pull up the code for it. Working on it. Working on it. Working on it. Where did I not go? Oh, way in the back. Oh, you know what I should do? Wait a second. If I put 5 hacky sacks in here, I might be able to make it. Let's try. Ready? All right, ready? Oh, there goes a hacky sack. All right. All right. Okay, good. Let's see. Yep, got that one good. Back to the demo. Okay, so what we're going to do is, yep, I want to run this. I'm going to run this thing. We'll fire up this solution from Visual Studio here. Oh, I hate when that comes up during a demo. I don't have any more working on it, though. Done. Really, it's going to go away anytime soon. Oh, there it goes. Whew. I tell you guys, 5 minutes before I was going to talk to you, I had that stupid dialogue that says Visual Studio is doing something, and I'll let you talk to me when I'm done doing something, and it's just going like this. Now if you're going, it's all right, it's going to finish before I have to start. Okay, I'm going to fire this one up in Chrome, not because IE doesn't support it, but because there's actually kind of a big difference between the speed at which the JavaScript runs in each one of these. So the demo's a little slower if I use IE. Okay, so here's what we're doing here. For this particular demo, what I wanted to give you is something that you could relate to. This is a type ahead scenario. So what I mean by type ahead is that I can come down here and I'm going to click on my little single threaded right here, and I'm going to come up here to my box that says start typing, and I'm going to type C-A-L, and you're going to see behavior that we're all used to, right? Where there's some back-end service that we want to talk to, and as I type ahead, I want this thing to be filtered down on my typing. So that's good. But now, the thing about this is what I'm doing right now is I'm running the single-threaded version of it. If you look up here, you can see I have the little single-threaded box checked, right? So the single-threaded box is checked. So this is not bad, right? It's not bad at all. You go, hey, that works fine. So one of the things that I think is important to understand about this whole idea of multi-threading is I'm not trying to make this run faster. I'm trying not to block the main thread. That's the issue. So what we find is that many times we don't really need a multi-threaded solution for something like this if the performance is okay and we're not doing other things and the main thread isn't getting blocked in a way that causes problems. So don't introduce complexity where that's not going to help anything. Okay? But then, if you have a scenario in which perhaps this thing becomes more intense, so I'm going to check my long running box here, and now when I type, I just typed C, and now I'm waiting and waiting and waiting. Oh, it came back. And then I type A, and I'm waiting and waiting and waiting. Now, you'll see that, of course, the behavior's the same, but I've artificially introduced some kind of delay. But here's what I want you to focus on. Here's what I want you to focus on. If you look at the cursor right here, you'll notice the cursor is not blinking. You with me on that? So let's see if we can see it together. There's the C right there. And when I come in here and say C-A, the cursor freezes. Because what's happening is the single thread is processing to go find those items, and it's not visible when it happens quickly. The cursor freezes, but it comes back from that operation. You don't see it. But if the operation is intense, you can see it's clearly blocking the main thread, and the UI won't update. In fact, there's something else that's supposed to happen here that isn't happening because the UI is not updating. Now I'm waiting for it to finish. See, I can't even uncheck the box. Did you get that? Now I can uncheck the box. All right, so what I'm going to do now is we're not going to do single-threaded. We're going to do multi-threaded. And let's do the long-running thing. And now I'm going to type the C, and uh-oh, isn't that interesting? You see that? So what was supposed to happen was you're supposed to see a little working on it thing, right? But you don't see it in the single-threaded version because it can't run. You'll also notice, if you look very closely up there, that the cursor's blinking throughout the entire process. See it? So what we're showing here is not blocking the main thread. It's not about making the type ahead faster. It's about making the UI responsive while you're doing something that's intense. That's what this web worker thing is all about. Okay, let's take a look at how that's done. Okay, so back into my solution here. Okay, so this is pretty straightforward stuff. I think very easy to do. You'll see that here I'm in app.js, so this is my main JavaScript code for the app. And then all I'm doing is spinning up a new worker by referring to this multithreaded.js library. So that's how you get your new worker against some JavaScript that you want to run. And then I bind an event listener to message. And this event listener is waiting for a return value. That's what it is. So we bind it up, we're waiting for a return value, and then what we can do is send messages over to it. There's the webworker.post message. So notice in this code right here, what's happening is when you check the multi-threaded box, then I'm going to send messages over to the multi-threaded worker using post message and ask it to do the work. Okay, great. So that's pretty straightforward stuff, right? We can do that. Now let's see how things work on the web worker side. So in this multithreaded.js, we'll pop this guy open, make this big. All right, so now inside of here, here's how we write it. See how it begins with self right there and add event listener? So I'm adding an event listener for messages so that when you post to me, I get the data you want. Well, what are you posting to me? You're posting the keystrokes at this point. And then what code am I going to run? Well, what I'd like to do is I'd like to go, find that filtered information. And in this case, what we're doing is I'm actually behind the scenes using a contacts list. See that? So the information that's working on the type ahead is a SharePoint contact list. So that's pretty cool. I'm making RESTful calls over there. Now, note how I'm doing it. XML HTTP request. I find this very interesting because talking about abstraction, when you see AJAX calls made in presentations, 99.99% of the time they use jQuery, right? Which is great. jQuery's cool because it returns promises to us and stuff like that. But just as a, sort of a public service announcement, did you know under the covers it's actually using XML HTTP request? So we've stripped away the abstraction of jQuery here, and I'm using the raw native support of the browser to make asynchronous calls. This is actually what browsers support. jQuery wraps it and makes it better for us. So what we're doing is we're coming in here making this asynchronous call. Here's the URL that I want to make the call to. You can see it's obviously a GET. And then what we do is we have this onReadyState change, which fires whenever the ready state of this object changes. You can see that if it's 4, there's some magic for you, right? So that's a secret decoder value. So if it's 4, that's good, life is good. And if we returned, HTTP 200, okay, right? And then what I do is I post back using post message, and I'm basically just sending the HTML. I actually generated HTML in here. So you can see I'm generating a series of list items, and I'm sending HTML back. So I think what's important about this is not just the setup, how do I make this happen, but what am I allowed to do in here? Because I said you can't come in here and touch the DOM. But I can create HTML and send it back, and then you could do something with it. Or I could send data back to you, and then you could turn it into HTML, which is probably better, right? But the point is you have to find a way to make that work. But the other thing I think is cool here is I can still make asynchronous calls out of the web worker. That's powerful. Because now I got a way out of the box. I could call my own web API service. I can call SharePoint lists. Whatever it is that I need done, I can now make that call from the web worker. And that really opens up everything that you could ever want to do with that multi-threaded processing. OK, so for me, the takeaway on that is pretty easy to set up. And if you know the XML HTTP request code, you can make that call directly from the worker out to anything you need. Why can't I use jQuery here? Yeah, the problem is it references the DOM, right? So I could try to import it. Remember, if you remember on the one slide, I said you can import other libraries and use them in the worker, but jQuery won't import here because it's so UI-centric, it fails to do that. So you need to roll back to the basics, which is why it's good to know this. Okay, coming around the clubhouse turn here. Last one we want to do. The last one I'm going to do for you is maintaining SharePoint context. So here's the challenge that we have. When you write multi-page apps, you get information when your app launches, right? So typically you get like the standard tokens that tell you what the host web URL is, what your app web URL is, that kind of stuff. And then parts of your app can be dependent upon that information, like say you want to call back into the host web. Would be nice to know what the host web URL is, right? But if you're in a multi-page app, you lose a lot of that contextual information when you go to the next page, unless you do something to remember it. So, you know, you can lick it, stick it, bind it on the end of the URL, pass it to the next page, stuff like that. And most of those are kind of messy. Of course, sidebar, it all goes away if you're doing a single-page app, but that's okay. Probably won't do those all the time. So our challenge is then, how do we maintain information like context in a SharePoint app across multiple pages? Well, what we're going to do is we're going to utilize web storage, and for fun, we're going to add geolocation into our context management in order to solve this problem. HTML5 supports web storage. Web storage is the idea of giving you a persistent data location. We have two ways to do it. We can use local storage, which persists, and session storage, which gives us session-level storage, all these accessible through JavaScript. This gives you a way to remember something. It's vastly superior to trying to fool around with cookies. You have more capabilities here than you have with previous ones. And it's also very clean, because I can take something like a JSON object, serialize it, put it in there, deserialize it, get it back out, and use it. So it's very powerful for being able to remember things like state. It stores things as key value pairs, so it's relatively straightforward. You could take that JSON object, serialize it, give it a name, store it by that key, put it in session storage, and get it later. The session storage is accessible to all of the different libraries, the pages, etc., that are in your app, so it gives you a perfect way to remember things across the entire session. And you can also handle events for data changes. So if you're interested in knowing when a library puts something in, you can receive an event for that. Here's some simple code on web storage so you can see how ridiculously easy it is. We have a couple of lines up there, local storage set item and session storage set item, which allows you to put something in either local or session storage. You can see it's just a key value pair, so you could store something simple like a string, or you could store something complex like a JSON object. Notice I'm using JSON.stringify to serialize my object before I store it. Retrieval is just as easy. You can do local storage get item, or you can do session storage get item. Notice that when I get the JSON object back out, I use JSON.parse to deserialize it. So now I have a great way to store JSON objects in my app. And finally, I have the storage event, window on storage, which will tell me when things change, so I can get the key that changed, the old value, the new value, and whether or not it was session or local storage that was affected, right? So one of the things I think really comes through when you're talking about all this HTML5 API stuff is, this is not that complicated, but actually the relationship of how complicated it is to program it to how much power you get is pretty significant. We really get a lot of benefits from this, and web storage kind of shines in that area. Okay, so what we're going to do now is our last thing, is we're going to show a demo of maintaining SharePoint context utilizing this. Let's go ahead and grab the code here. And jump over to the page where I have the app. Oh, we got to see the screen. You're nice for saying that. Otherwise, you just let me go for a while until I do the whole demo and then say, hey. All right, so let's go to the actual demo here. Here's the context app. Okay, so this is pretty straightforward. You can see the messages popping up over there in the upper right-hand corner saying that session storage has been affected. So I'm just popping up messages when session storage comes along. What you're looking at here is a context object that I created. So I sat down and I thought to myself, I said, okay, there's things like host URL, web URL, stuff like that, app URL that I might care about. But what other things would I care about if I really wanted to remember important things about the app and who's using the app and things like that? So you can see that this particular thing has information about the user for sure, and it has the standard tokens inside of it, so you can see things like language and client and things like that. But look, I also put the form digest in there. So whenever you do updates to SharePoint lists, right, like puts and posts, you're expected to provide the anti-forgery token back to SharePoint that we call the form digest. The form digest has a lifetime, and you need to remember it in your app. Otherwise, you've got to get it every time before you perform the operation. So why not just put it in storage so that we can have it? And then this particular code, I won't show this to you, but you have the source code for the session. This particular code has a set timeout on that anti-forgery token, and if the anti-forgery token times out, it just automatically goes and gets another one for you. Isn't that nice? So we know that all the context information that we care about is contained in there. And for fun, I also did the geolocation stuff, but because of the way we're connected and everything, you can see that basically I get a permission denied here. But if geolocation was authorized by the user, I'd have your lat long in there as well, okay? Now, to prove this works, what I'm going to do very simply is go to another page. Now, the Chrome control in the SharePoint app model is used to make an app look kind of like the host that it came from, right? You familiar with the Chrome control? But the Chrome control relies on knowing the URL of the host web so that it can doctor up your app to look like the host web. So you have to pass that context around. So in this case, if you look up here at the URL, we go ahead and pull this out, you're going to see that the host is passed in. There it is right there, the SP host URL. So when I get on the home page, I could use something like the Chrome control to point back to the host URL and say, I want to look like that. And the Chrome control would style me to look like that. That's great. But what about the next page? Well, what we're going to do is save that information in the context, and then we're going to navigate to a next page here. I'm going to click on that next page, and you can see the Chrome control has politely styled this page so that it kind of looks like the host. But what I want to point out to you is there aren't any query string parameters. You with me? I didn't have to bolt them onto this URL and pass it along because that information is maintained by the context object inside of web storage. Okay, so let's take a look at the code for that. Everything we really care about is in this library called wingtip.contextinfo. Again, this is in the source code for your session, so you guys have this. Come on. Oh, boy. Doesn't go this time, we'll just open it in Notepad, but it's going to go. It's going to go. No, I ran out of shirts. Okay, there we are. Save me. All right. So you can see here that this is a pretty straightforward module. That's about it right there with everything collapsed. I have a get and set context, but the stuff that we care about here is the initiation, init base, init user, init location. This particular thing right here, what it does is it allows you to initiate the context in separate sections. So if you really don't care about geolocation, you don't need to initiate that part. Just do the part that you want. But for us, what we really care about here is we care about how it gets stored and retrieved in session storage. So it's really this ridiculously simple. You do a set item, and I'm basically taking that entire context object, I'm serializing it and storing it as app context object, and then I can pull it out again and get to any information I want, right? I mean, I've decided what information I care about in this demo, but you guys could certainly put whatever you want in there, and it's really that simple to read and write that information out. This entire thing uses promises. It's all set up based on promises. So what I think is cool about that is using the library is as simple as this. So what this line of code does is initialize the context. You can see the inits that are in there. And then when the context is completely initialized, it calls the knockout bindings and draws the page. So the other thing that's cool about this is this model gives you a really neat way to have the beginning of your page model. Initialize the context, and when every context operation is done, start the app. Okay? All right, so something else to think about. Okay, we're right at the end. Let's go ahead and zip on back to the slides and wrap it up. So here's what we did. I showed you a bunch of different solutions. Now, these were all meant to be practical things, ideas that you guys could take with you and incorporate in your apps. You have the source code for every one of them, and give you some real, ideas that, hey, HTML5 is stuff that I should start to do. If you're interested in the things that I did, we have more stuff coming up. This was 413. I'm doing SPC 400 and 404, which basically just expands on a lot of these ideas. So third-party libraries, we'll be talking about things like Angular, and then build your own REST service. I'll be going into more detail in the web API stuff. All right, and the end is all the commercial stuff I need to do, like please make sure you evaluate this session unless you didn't like it, in which case, don't worry about it. All right? I'm done. Thank you very much.